All right, we're talking about the Outdoor Economic Impact Toolkit as part of the Building Outdoor Communities program. And my name is John Whitehead. I'm a professor in the Department of Economics at App State. And the text for our conversations is Recreation Economic Decisions, Comparing Benefits and Costs, the second edition. This is a 1997 book, and the copies of the readings are available in your Building Outdoor Communities folder. And so far we've talked about measuring quantity, measuring price. And this video looks at recreation demand. And we'll be covering pages 55 through 65 of the book. Okay, so demand curves can be used in many ways, and these are recreation demand curves. If you've had an economics course previously, the demand curves that we're going to be talking about are just like the demand curves for something other than outdoor recreation. For example, a pizza or an automobile. Okay, the only difference with the demand curves we're talking about today, these recreation demand curves, is that we have a different measure of quantity and a different measure of price. Okay, so these demand curves can be used to estimate the recreation benefits received by visitors, and this is the sort of number that you would use in a benefit cost analysis of an outdoor recreation infrastructure project. And these demand curves can be used to predict future recreational site use at different prices. And although we don't talk about it in this chapter, changes, or these recreation demand curves, can be used to measure potential changes in visitation at recreation sites if there's changes in the quality of those sites. Okay, so on the right here, we've got what's known as a demand schedule, which is a table that lays out the number of trips that would be taken to a recreational site at a different price at different prices per trip. Where these prices per trip are the sum of entrance fees, transportation costs, and time cost. Okay, so what you can see is that with these made-up numbers, as the price of the trip goes down, the number of trips made by an individual increase, and that's known as the law of demand or the principle of demand. And we have that relationship for three reasons. First, the number of trips that people can take is constrained by income and budgets. Okay, and there also might be a less expensive substitute recreation site. So if the price per trip is $80, you may feel you can only afford to take one trip. Or if the price of a recreation trip is $80, there might be a recreational site closer to home whose price is $30 that you would rather go to at that price. And the third reason is what economists call diminishing margin utility, where utility is a term that is synonymous with happiness or enjoyment. And the idea here is that if you, the more trips that you make to a particular recreation site, the less enjoyment you get from each additional trip. Okay, so you might make 4 trips to your local park, and after that, you decide to go somewhere else. Okay, because somewhere else might seem new, and you might see something different, more interesting. You may have learned all you can at the park that's close by your house. Okay, so this is a demand schedule. If we graphed this demand schedule with price per trip on the vertical axis and the number of trips, the quantity, on the horizontal axis, you get this downward sloping curve. Now, as a side note, economists flip the axes from the way you typically think about how something is graphed in math, where the dependent variable, or the behavior that you're trying to explain, is graphed on the vertical axis, and the independent variable, or the number that you know is out there, you don't have to predict, is graphed on the horizontal axis. And this was done, in 1896 or around there, by the first economist who developed demand and supply analysis, and we've used it that way ever since, even though it confuses undergraduates. Okay, so here you see we've got the this line with the circles. Okay, this reflects the price and quantity combinations in the demand schedule. So at a price per trip of $80, we have one trip. And here you see one trip and $80 is this second circle as you move from left to right down the demand curve. Okay, and this demand curve can be used to estimate changes in recreational use at any price that the individual faces. Okay, so another important thing that can be done for policy analysis is to estimate the benefits with the demand curve. And when we think about benefits, okay, so that's an economic measure of how much pleasure or utility, enjoyment, the consumer gets from pursuing that activity. And another way to talk about benefits or marginal benefit, additional benefit of each additional trip is to think of that in terms of willingness to pay. Okay, so the consumer's willingness to pay for a trip is a measure of the benefit of the trip. So the height of these bars here, I've replaced the downward sloping demand curve with a bar chart. And so here at one trip, we would interpret the $80 as a consumer being willing to pay $80 for that trip. Now that is a maximum willingness to pay. It's not like the consumer wants to pay $80 for something if that's their maximum. Okay, it's similar when you go to the store and buy something, and you might have an idea of the maximum you want to pay for that good, but you're going to shop around and try to find better prices. Okay, so that you enjoy some benefits of the good that you don't have to pay for. And with this benefit and cost framework, we think that consumers should or will take trips as long as the benefit exceeds the cost, where the cost is measured as the price per trip. Okay, so in terms of estimating benefits for benefit cost analysis, on this bar chart, I've drawn this horizontal line, and we're going to say that for this consumer, the price per trip is $40. So in that case, the consumer is going to take 5 trips. So as long as the willingness to pay $80 is greater than $40, the consumer will take a trip. So for the second trip, willingness to pay is 70, third trip, willingness to pay is 60, fourth trip, willingness to pay is 50. So the consumer will take all of those trips because willingness to pay is greater than the price or the cost. And then on the fifth trip, willingness to pay is 40, so you're just indifferent between taking the trip or not. Okay, and the difference between willingness to pay and cost is considered the economic benefit or the economic value of that trip. So if willingness to pay is $80 and the cost is 40, then willingness to pay is the net willingness to pay. And another term for that that's used in economics is known as the consumer surplus, because it is the extra benefit that consumers get from consuming a good. Okay, so here we are back to the demand curve view of this situation. So we've got the same willingness to pay values indicated by these blue circles, and then the horizontal line represents the cost per trip for this individual, and then this dotted line indicates that they're going to take 5 trips. So that the total consumer surplus is the money that would have been spent on the trip, but wasn't because of the low price. Okay, and you can. This is this is less tangible than when we talk about economic impacts associated with a recreation site, where economic impacts are based on the money spent by those visitors in making that trip. Okay, but this consumer surplus is no less real, because think of the market situation. If you think the maximum you're willing to pay for some market good is $80, you're going to shop around, and if you find that good sold somewhere for $40, then your consumer surplus is $40, and that is $40 that you can spend on something else. Okay, so that's real income. Okay, and what economists do is estimate these demand curves for outdoor recreation, and what you do is develop a linear relationship between a linear or nonlinear relationship between price and income, or price and quantity. Okay, so where quantity is number of visits to an outdoor recreation site, and price is the transportation time and time costs and interest fees. Okay, and if you can collect survey data and estimate the demand curve statistically, you can apply some numbers to these vague abstract terms A and B. So the line to the right is Q equals 9 minus 0.1 times price. So to see how that is graphed, just set price equal to 0, and you get Q equals 9. Okay, and that's the horizontal intercept of that demand curve. Okay, and then if you set quantity equal to 0 in this equation and solve that algebraically for the price that makes quantity equal to 0, that price is going to be $90, and that's the vertical intercept of this demand curve. And then consumer surplus, or net willingness to pay, can be estimated as the area of the triangle below the demand curve and above the price line up to the number of trips. So the triangle that goes from the vertical intercept of 90 to the point where quantity equals 5 and price equals 40, and then over to the left to the other vertical intercept of 40. Okay, so the area of a triangle is 1/2 base times height, and so consumer surplus, or CS, equals 0.5, or 1/2, times 90 minus 40, which is the height of the triangle. So we go from 90 to 40 on the vertical axis, times the base of the triangle, or 5 units. So just a little bit of math. Consumer surplus equals 1/2 times 50 times 5, and that's equal to 125. And a lot of times you'll see this expressed as consumer surplus per trip, where we just divide consumer surplus by the number of trips. So that's equal to $25. Okay, and one note, we are able to estimate these downward sloping demand curves. They might be linear, they might be nonlinear, and get an estimate like $125 for the area of that triangle. We don't usually have information on the willingness to pay per trip for all of these trips. So if you notice, if we add it up, let's look at this picture. The net willingness to pay from this graph will come up with a different answer than $125. Net willingness to pay for trip 1 is 40 plus 30 plus 20 plus 10. So that would be equal to $100 total. But don't let that difference trouble you, because in the end, when we're looking at a lot of different individuals in estimating these demand curves, that kind of information. That kind of difference is trivial in the grand scheme of things.